For number 1, we're going to add together our x terms and divide by 2. And we're going to add together our y terms and again divide by 2. This gives us our midpoint. So 6 divided by 2 is 3. And negative 6 divided by 2 is negative 3. A similar thing for number 2. I take negative 2 plus x plus 2, all divided by 2. And negative 6 plus y plus 3, all divided by 2. When I combine these like terms, I end up with x over 2 and y minus 3, still divided by 2. And that's as simple as I can make it. For number 3, consider that I am taking coordinate 1, coordinate 2, and I'm using the formula to find my midpoint coordinate, typically. But this one's different because we are given the midpoint in one of the coordinates. So we plug those in, and we find that 2 plus some other value of x added to it, divided by 2, is equal to this midpoint, negative 1. For the y's, I'm going to take 4, the known y value, plus some other y value, divided by 2, is equal to the midpoint, 1. Here's just a two-step equation. You double, you subtract, you get x is equal to negative 4. You double, you subtract, y is equal to negative 2. So my final coordinate I could write as negative 4, negative 2. So this first one, AB, I'm going to find the length by pretty much doing the Pythagorean Theorem. I count over 1 and down 1, 2, 3, 4, 5. So I'm going to build this triangle. It's a right triangle, and it has the side lengths of 1 and 5, and the hypotenuse is my distance, AB. I plug in 1 and 5 to this equation. I get 26 is equal to c squared, so the distance is equal to the square root of 26. If I wanted to perform the similar process for BC without using the Pythagorean Theorem, I can just consider the distance formula, and I can take my second x coordinate, negative 2, and subtract from that my first one. And I can take my second y coordinate, 0, and subtract from that my first one, negative 1. And if you take the square root of negative 5 squared plus 1 squared, it turns out to be pretty much the exact same thing. And if you had counted up 1 and over 1, 2, 3, 4, 5, you could have recognized that. It's also the square root of 26. So for C and A, I'm going to take the square root of the second x coordinate minus the first squared plus the second y coordinate minus the first squared. So this is negative 4 squared plus negative 4 squared. Or in other words, the square root of 16 plus 16, which is 32. It doesn't really matter if you choose to use the distance formula, the Pythagorean Theorem. They accomplish the same thing in the same way. Whatever you're more comfortable with is fine. Though I will say the distance formula is a little bit easier when you don't have a drawing. You can just directly punch in negative 2 minus a negative 7 squared plus 0 minus a negative 4 squared. So this becomes the square root of 5 squared plus 4 squared, or the square root of 25 plus 16, which is 41. To use the Pythagorean Theorem for number 9, we can draw a triangle here and look at the difference between these two x coordinates, and see to get from one to the other you'll have to travel 11. And then we can look at the distance between the y coordinates, and we see that there's a distance of 3. So I guess this triangle should be flipped, but it doesn't really matter, because we take the square root of 11 squared plus 3 squared, or the square root of 121 plus 9, the square root of 130. So for exercise 10, if we draw out a pool table that is 12 feet long and 6 feet wide, and we measure from corner to corner, what we should realize is we're pretty much cutting it into a triangle that has a dimension of 12 by 6. So we're going to take the square root of 12 squared plus 6 squared. And if we add together 144 plus 36, we get the square root of 180 in feet. They want it to the nearest tenth, so we could call that 13.4 feet. Number 11, we can see that the side lengths are both 6 feet of this triangle. So we can take the square root of 6 squared plus 6 squared, or the square root of 72. They want this rounded to the nearest tenth, so 8.485 gets rounded to the nearest tenth and becomes 8.5 feet. Number 1 asks us to find the perimeter of ABC. So what we can do is we can turn this into 3 separate triangles, 3 separate right triangles. And we're going to use the Pythagorean Theorem to figure out the hypotenuse of all of them. If you count the squares for each of these triangle sides, you get the following figures. And we're going to figure out the first distance as the square root of 9 squared plus 6 squared, which is the square root of 81 plus 36, or the square root of 117, which rounds to 10.8. And we'll just say units, whatever the unit might be. So I'll do the blue one next. This becomes the square root of 11 squared plus 4 squared, or the square root of 121 plus 16. And if I take the square root of 137, I get 11.7. For the green triangle, I take the square root of 5 squared plus 5 squared, and I get the square root of 25 plus 25, or the square root of 50, which is 7.1. The next final thing to do is I add together these 3 distances. And the perimeter of this triangle is 29.6. So to find the midpoint of any of these segments, we can just average their x coordinates together. Here we take negative 5 minus 1 and halve it, and average the y coordinates together. So we would take 8 minus 3 and halve it. So for AB, my midpoint is negative 3, 2.5. For BC, I do the same thing with negative 1 plus 4 divided by 2, and negative 3 plus 2 divided by 2. And this gives me a midpoint of 1.5, negative 1/2. For CA, I add together negative 5 and 4 divided by 2, and 8 plus 2 divided by 2. So the midpoint for those two is negative 1/2, 5. Well, I confess for number 3, just by knowing the definition of midpoints and how long these lines will be, when you find the perimeter, they're all going to be half of the original value. So we could take the 29.6 and just divide it by 2 to get 14.8 units. And that's what number 4 is asking about. Triangle ABC. Perimeter is double the new triangle. For number 5 and 6, we're going to use QS and RT to find the lengths of those diagonals and then the midpoints. So if I plug these both into this distance formula, and I take the second minus the first, the second minus the first, I do the subtraction accounting for the negatives, and I square them to get rid of the negatives, combine, take the square root, and round to the nearest tenth. I get 12.2 between Q and S, and 16.1 between R and T. If I wanted to find the midpoints, I can just add together the x coordinates and halve them, add together the y coordinates and halve them, and I'll get 1, 1. I could do the same for the other, but I should know that they're going to be the same because the diagonals of a quadrilateral cross at the midpoint, which is going to be 1, 1. For 7, we look at what the definition of a diameter of a circle is, and that's a line that crosses from one endpoint to another. So we can take the midpoint of these two coordinates, add up the x's divided by 2, add up the y's divided by 2, and we get this coordinate 119 as the center of the circle. For part B, to find the circumference and area, we want to figure out what that actual diameter is. So we find the distance between these 2 points, J and K, by using the formula. And let's leave that as the square root of 628 for now. We'll save the rounding for the very last step. So if the circumference is equal to pi times diameter, I can just take the square root of 628 multiplied by pi, and if I do that in a calculator, the very last rounding step will give me 78.7 units. Then to figure out the area, I can plug in that diameter divided by 2, and the answer is 493.2 units squared. For part C, I know that 119 is the center of my circle, and my diameter is about 25, so my radius is going to be half of that, and radius is going to be somewhere around 12 and a half. I have to go 18 units straight down to get to this point, which is not going to happen because the radius is only going to reach part of that way, so it's not on the circle. The distance is equal to 18, which is bigger than 12.5.